Okay. Not sure if streaming or not yet. Still. Basically, YouTube went and changed some stuff, so trying to get to my stream. Okay, it appears so. Test. Okay, it appears so. Test. Okay, it appears so. Test. Okay, going to reset since I don't need 3 minutes of fiddle messing around. So test 2. Test 2. Test 2. Okay, so forgot about the really narrow angle on this webcam. So, and its inability to see crap. Yeah. So FPGA board is a Nexys A7. Oh, that's what I have my core running on. Let's see if I can do anything to improve focus. Yeah, it looks better. So, FPGA board connected to a VGA cable. Which goes to a monitor. I'm now going to fire up the FPGA. Let's see if it does its magic. Or if I'm in the thing in the fog. Oh, there it goes. It's monitor view. I also have a terminal view of stuff. That's coming through. That's coming from an FPGA chip, which is, you know, debug UART, but so I have a keyboard, but so yeah, I can type commands on the keyboard, and in this keyboard, it connected directly to the FPGA, or connected to the FPGA board via USB, but as far as the FPGA sees it sees it as a PS2 keyboard. It's also possible to type commands via the serial link as well, which maybe or at least it was working before. Okay, there it goes. So type stuff on my main computer, and it goes to the FPGA, and they're displaying more or less the same stuff. So yeah, in case anyone's getting nauseous from my camera holding skills. Surprisingly, I don't actually need to get up to get more or less a full screen view of the thing. Just a difference from my phone, because I have to hold my phone fairly close to get mostly full screen. But this webcam has a fairly near, seems to have a fairly narrow view angle, so yeah, it's looks like I'm holding it right up, but it's actually like good 4 feet away or so. Yeah. Yeah, it's a webcam view from about halfway across my bedroom as it is. But my room isn't exactly large. But so yeah, that's basically the test kernel shell there, which is more or less a really rudimentary OS, essentially DOS-like in that it has no memory protection and such. But yeah, no memory protection, and anything running on it more or less has direct access to the hardware, because no real hardware abstraction layer as of yet. The FPGA prototype does have an MMU, but I'm not using it as of yet. And main thing I'd probably use it for is essentially virtual memory to well, allow more stuff, and probably back that stuff onto the SD card as page file. The FPGA board I'm using is a Nexys A7 with basically an RISC 7 with 100,000 LUTs and 128 megs of DRAM. So yeah, but I can should be readable from the debug serial. Firing up Doom. And see if it will be cooperative. With this stuff, it can sometimes either boot correctly or it can crash. Not super reliable as of yet. Even if it worked, you know, earlier, there's no saying it will necessarily work. So, running an Ultimate Doom WAD here rather than the shareware Doom WAD, but that's what I was running before. It's the shareware Doom WAD, but yeah. You're going to get menu. BJX doesn't appear to have frozen yet, but okay, yeah. There I get menu. And there's the demo. And we see crap is a bigger mystery. There's a bunch of glare here, it looks like, and it's yeah, I'm trying to get the camera lined up again. Disadvantage of a camera with a narrow view angle is, you know, fairly small hand movements will cause it to point off somewhere weird. I am freehand holding it right now. Annoying. But, looked like key stuck there. An issue I haven't quite figured out yet is the matter of keyboard. Namely, sometimes the keys are sticking and stuff. So yeah, but if it were more visible, one can see at least that Doom is key stuck again, so I started wandering off into the distance. Come on, keyboard. Yeah, the keyboard issue is kind of annoying. But, especially when I'm trying to operate the keyboard and the camera at the same time. And, you know, have to look back at my main computer to see if the camera is still pointed at the monitor. See if I can figure out some sort of better solution to this. Also glare. Glare isn't helping. I'm going to see if I can see if I can resolve the glare issue somehow by well, covering up a window. Attempting to thing I'm trying to mount the camera to isn't exactly all that stable itself, so I question is, can I get it pointed at the monitor? Appears so. Of course, touching the wire disturbs the camera, but I'm on camera. You know, what's the glare coming from? Oh, I think it's the light. If I can get it stable enough where it more or less points it at the monitor, that'll be good. The frame rate in real life is at least slightly better than it's coming from the webcam, but not really by that much. Well, except when it's really obviously laggy, and then that's because it is in fact kind of laggy in real life as well. But so yeah, it's Doom running on the BJX2 core. Its frame rate is, well, not particularly good. And keyboard stuck, which is pretty annoying. Have to figure out why it's doing that. Basically, it seems to be missing either key presses or key releases. So yeah, when it misses key presses and key releases, the keyboard key kind of gets stuck on. Just sort of have to hit the key again to unstick it, but it is kind of annoying. I'm not sure yet whether that's due to the an issue with the FPGA hardware, or actually the Verilog code running on the FPGA, or if it's due to the USB to PS2 interface or the keyboard or what. Seems to happen more often if one hits multiple keys at a time. But yeah. Kind of annoying because, you know, to operate Doom effectively, one has to, you know, typically hit multiple arrow keys at the same time, and other keys like control for firing and so on. Besides, PS2 could theoretically use the buttons on the FPGA, but that would be, well, even less convenient. So yeah, now I'm at the second map for the first episode. As can be noted, well, this is so yeah, multiple keys have caused the keyboard to stick, and I'm getting shot at. But you know, I have plasma gun because this is the ultimate Doom wad. Being it's the ultimate Doom wad, I can also hold on. Yeah, don't exactly think, yeah, no one's watching right now anyway. I just clicked there to enable the chat in the off chance anyone does show up, which is, well, unlikely, but yeah, so being as this is the registered Doom, I can do other things like go to different episodes. Technically it does have sound, but it's, you know, not coming through my main computer. Some earbuds. Hold these up to the microphone, see if I can make it audible. Yeah, that sounds like crap. sounds like crap. Yeah, that sounds like crap. Yeah, I don't have direct feedback on the audio, so just listening to it come over the stream, and that comes with a bit of a delay. Yeah, that sounds like crap. Yeah, I don't have direct feedback on the audio, so just listening to it come over the stream, and that comes with a bit of a delay. Yeah, that sounds like crap. Yeah, I don't have direct feedback on the audio, so just listening to it come over the stream, and that comes with a bit of a delay. Yeah, I don't have direct feedback on the audio, so that bit of a delay. Well, you'll just have to take my word that there's audio. It is, of course, coming out over an earbud, so it is not very loud. And holding it up to the earbud has not led to particularly satisfactory results on that front. But yeah, I'd have to have some sort of, line in or something. Yeah, somehow the combination of dude has showed up. Yeah, but so yeah, the combination of like not particularly high frame rate from the Doom being shown on the FPGA, and the lag of the webcam has compounded to make a not particularly high frame rate experience as seen on stream, but it is at least slightly better in real life. And yeah, it works slightly better if I look at the real world monitor rather than the webcam capture of said monitor, because the webcam adds some delay, and also doesn't look good, but I end up having to look at the webcam view of things to be able to see, well, the webcam view of things to see if it's, still capturing. One thing the webcam doesn't really seem to be picking up on that much, but it's more obvious in real life, is that there's actually quite a bit of noise on the VGA output from the FPGA here. Basically, the FPGA board I'm using only has a 4-bit DAC for the VGA outputs, which means that in order to achieve like stuff, Yeah, and in order to achieve like more than, you know, a really coarse gradient, I need to sort of PWM the outputs to the VGA pins, but this monitor, it doesn't like that. So it generates quite a bit of a snow effect. But, you know, it's a trade-off between really noisy speckly output or output which has only a fairly small number of levels. So yeah, because only part of the voltage range is actually used for the video signal, I don't have a full actual 4 bits of dynamic range on this. It's closer to around 3 point something bits. Is basically well, it's kind of like NTSC in that sense. Namely, you have a white level that's not quite 100%, but it's, you know, like let's say about 80% or something. So you at about 80%, there's your white level. Everything above that is like above white level. But then you have roughly about another 20% that's your black level. And typically things below that point only really occur during retrace events. So yeah, the actual black level you'd drop to on the front porch and back porch area would be, say, like roughly 20% of your voltage level, and then during the actual H sync and V sync intervals, then during the H sync and V sync intervals, that's when you actually drop down to the real 0 volts level. And you basically have to drop down to 0 volts at that stage, otherwise otherwise the monitor's not happy. So it's, you know, at the same time you drop down to 0 volts on the RGB pins, and you also assert the H sync or V sync signals respectively. And then they have to basically happen at the same time, otherwise in this case the monitor will fail to do its H sync and Z sync properly, which is kind of a problem. In addition to the dropping down to the 0 volts for H sync and V sync, and racing to the 0.2 volts for the front and back porch area, it's also important, at least with this monitor, I don't know about others, to, well, not PWM the front and back porch regions, because if I PWM the front and back porches, then, well, the results don't look good. It causes some pretty severe flickering. So basically, yeah, if I PWM the front and back porch pit regions, it causes these really obvious, like dark and light bars across the screen. Like similarly, PWMing during the during the vertical sync area also causes problems, like along the lines of strobing and stuff. I kind of wonder if it's a similar effect to how Macrovision worked on old VCRs or something, but yeah, this monitor is kind of fuzzy about that. I've not tested with an actual analog monitor. When I came up with the idea of, PWMing or PDMing the output to the RGB pins, that was with the sort of working assumption that, the monitor would just sort of average it out to a single voltage level. But sort of works, but also sort of generates a lot of noise. I'm guessing maybe this monitor isn't using a DAC that will, or an ADC that will instantaneously measure the RGB input voltages, but might approximate it or something. So it seems to generate actually a bit more noise than is actually the sort of coarseness between the different voltage levels. Like if I just give it a 4-bit levels, it's looks bad, but it's not quite as bad as the amplitude of the noise. But despite there being noise, the webcam seems to itself be able to filter that out to some extent. So I've noticed that when taking pictures of the output or apparently using the webcam, is that the webcam seems to, the camera seem to average out the actual rapid noise in the video to a more consistent voltage level or more consistent brightness level. But in real life it's pretty obvious. But it's a trade-off of I either have noisy video or I have some sort of coarse approximation with only a few brightness levels that kind of looks not very good. So moral of the story, I think, is probably if one wants good looking output, they'll need more than a 4-bit DAC. Either that or a monitor that can average this crap or this stuff. But yeah. Yeah. Of course, with no audio feedback here, I don't necessarily know when guys are angry or wandering around, but to be expected. As can be told, the basic moral of the story is, yes, Doom seems to be working, more or less. Keyboard issues and crashing aside. in the basic sense, everything in Doom does appear to be working. It's mostly just prone to randomly crash after a little while. So yeah. Now the question is, can I return to the command line without it crashing and rebooting in the process? Yes, it has worked this time. So yeah, can be noted that when it works, it is able to exit back to the command line without, triggering the FPGA to crash and fully reboot itself. As for memory cleanup and other stuff like that, that's kind of yet to be done. So whether Quake will work or not, once launched after Doom, is to be seen. It could work, or it could run out of memory, or otherwise randomly crash, so we will see. But if it works, what'll happen is in a moment it will start playing the demo at an incredibly low frame rate. I could show the blinky LEDs on the FPGA, but don't want to disturb the camera. Playing enough already. As can be seen, this frame rate is not exactly playable, but it is a case of, well, at least the demos kind of work, sorta. Actually, Doom's frame rates, I can improve those slightly by making the window a little bit smaller, but yeah, it's semi-usable otherwise, all things considered, but semi-usable at least until it crashes and until one gets sufficiently annoyed with all the keyboard sticking. But yeah, Quake is less effective right now, so and it has crashed. Normally I need to try to start a new game before it crashes, but will the reset button work? That is itself a mystery. So I will try it now. Okay, yeah, so that's what it looks like in a full reboot. It basically, well, rebooted. there is food, and I kind of want to get food in not too long, but I was going to finish up demonstrating this for a moment. Not going to be too much to demonstrate with this, because as noted, its stage right at the moment is only really the demo's work, which is still working on that. Need to find whatever bug is causing it, or whatever bugs are causing it to not work, but it's slightly different than what it was before. Before it would hard freeze as soon as one tries to start a new game, but this time it well, usually doesn't. It does something different. Yes, this is what it does. Basically, progs, or the progs thing fails to well, work, and it froze. Doesn't always freeze, so sometimes it, like, just dumps it off to the Quake console, and it will hang out there on the Quake console for a little while, and have its blinky light, and it will also finish printing. But this time it has, well, crashed early. I think it's because I did a reset earlier rather than a full power cycle. And will the reset button work this time? Yeah, reset button still works. That means it's probably triggered a breakpoint or something rather than actually deadlocked. There is a difference there, but it is prone to deadlock sometimes, in which case the reset button will not work. So actually, if someone pays attention, they can see the exe files, which are the binaries which can be run to do stuff. Unlike an actual Unix shell, and kind of like CYG when it's in this sense, you don't actually need to type the exe, because it'll or the command line will infer that little detail there. But the exe is kind of used on the file so that test churn knows it's an exe. I'll probably add some other extensions that it might probe for as well, but like sh and similar. But it'll actually rely on file magics to identify what type of executable it is. So as can be noted, the Doom exe in this case is about 312 kilobytes, and the Quake exe is 354 kilobytes. Though, as noted, those values are slightly unfair if you are comparing them against, well, normal x86 or similar exes, because, well, my compiler does sort of use binary compression, but yeah. No. But yeah, if it wasn't compressing the binaries, the Quake exe would be closer to around 500 and something kilobytes, and the Doom would be, well, also somewhere in that area. So, but yeah. So yeah, they're internally compressed using a variation of the LC4 scheme, which basically works. It was tweaked slightly to allow the binaries to be decompressed without needing to use a full separate buffer. So rather than needing, say, an entire buffer for the compressed version of the binary and another buffer to decompress it to, all you need really in this case is the decompression area and a 1K or so intermediate buffer. So yeah, I can stick the temporary buffer for decompression on the stack or similar. So that makes decompression easier, and LC4 also can be decompressed reasonably quickly, and also doesn't need Huffman decoding, which again makes it easier. More so, the current prototype core is not exactly fast, so things like Huffman decoding would add a fair bit of a penalty versus LC4. Yeah, and can be noted, one pays attention, they'll also notice that .bit file there. That's actually related to the FPGA itself. That's the FPGA bit stream. So the FPGA bit stream is noted as around, well, almost 4 megs, so almost the size of that Doom 1 watt with an _0. That's because that's the shareware watt, but I sort of disabled it because I stuck on the Ultimate Doom full Doom watt. And the full Doom watt is capitalized because, well, yeah, because the flags are probably set to indicate that it's uppercase. I'm still a little bit on the fence as to whether or not the test kern file system will be case sensitive or not. Currently it's sort of in this middle area where it'll be case sensitive for long file names, but it will be not case sensitive for short file names when doing lookup. But I might make that behavior more consistent in the future. And as noted, well, when you consider that, yeah, that's currently done by the file system driver, and if you added, like, some sort of intermediate directory abstraction or similar like you do on Linux, well, then those rules would kind of lead to a big ugly mess. So you'd need consistent rules in terms of case sensitivity and other stuff, as opposed to leaving it up to the file system driver and having it go a little bit willy-nilly there. But yeah, as can be seen by, well, both the general file names and that random system volume information folder, yeah, long file names are supported. Similarly, directories are, sort of. So I can cd into the ID1 directory, and as noted, well, yeah, I only have the shareware pack on here, it looks like. When I had it set up previously, I did have the full registered version packs on here as well. Well, then I ended up reformatting the SD card in order to use a smaller cluster size. So that kind of well, got rid of the pack file. later on I probably will have a more proper directory tree as well, but this is sufficient for testing. So, yeah, yeah, and the actual bootload.sys with the ones without the underscores, yeah, that's the one that's actually booted to. The ones with underscores are basically a few prior versions, and mine's just being lazy and renaming them rather than flat out deleting them. But in any case, yeah. But so that 51 kilobyte binary, that's the shell that we're looking at. That's also essentially what passes for a kernel on this thing. So that's what has the memory manager and file system driver in it. As opposed to the Quake and Doom binaries, which also have their own copies of, well, the memory manager and file system driver, but they don't use them when launched from the shell like this. So they'll use the version provided by the shell binary. This shell binary, the bootload.sys, functions in this case as both the shell and as the kernel. So it's kind of, well, in MS-DOS sense, it's like kind of like if IO or IO.sys and command.com were rolled into a single binary. Then there was also MS-DOS.sys, which was, well, pretty sure it was, you know, just sort of there, and in the Windows 95 version it was replaced by, like, you know, some config settings and stuff like in DOS 7. I don't remember what purpose it served in prior versions, but I do remember it was kind of small and didn't serve much purpose. Don't remember if it was actually required to boot or not. I would, well, have to test on that front, but yeah, I think if I remember correctly, it's like io.sys was the main boot binary for MS-DOS, followed by, well, it loading command.com, which was, you know, your command shell. Yeah, it was, if I remember correctly, it was io.sys would then load config.sys and basically execute the commands there, like in terms of environment variables and stuff, and then it would load config or command.com, which would then load autoexec.bat and run that for the initial state for the DOS shell. But yeah, I don't yet have an autoexec feature, but I may or may not add that. And whether I'll go with an SH extension or a BAT extension or a CMD extension for the command shells, I have not yet decided. Unix tradition would dictate SH, but then again, I am using exe extensions as well, and yeah, Unix doesn't exactly use exe extensions traditionally, so that's to be decided. Technically, I do have some other commands that I can do, like, you know, for copying and moving files and stuff, but don't want to try them here because don't really, well, I prefer not to corrupt the SD card, and these things haven't exactly been working super good as of yet. So yeah, Because if I corrupt the SD card, then I'd have to, you know, reformat it and then copy the crap over, or all the stuff over to it again. And would prefer not to. Hmm. Hmm. Oh yeah, as noted, as can be noted, yeah, the Doom WAD for the full registered version is 12 megs. And OPAC is, well, almost 19 megs. So the data files, well, are the bigger files in this case. Contrast to, well, the kilobyte ranges for the binaries, which would probably be smaller, except my compiler produces binaries which consist of around 30% of move or of load and store instructions, and if you include push and pop instructions for, well, the stack frame and other stuff, then yeah, it's about 55% of the binary or so is, you know, just those instructions. In an ideal world, they would be a lower percentage than that, but but that's mostly the fault of my compiler, which is not super good at, you know, not using more loads and stores than necessary, especially with small blocks and loops and similar, or small if blocks and loops, because whenever it moves from one basic block to another, any variables that were loaded and then modified end up, well, needing to be written back to their associated locations on the stack, and that is not super efficient. Ideally, you would be able to figure out, okay, the value for this variable is never used again, so I can discard it. But would need to figure that out. It is at least smart enough to where for the top several variables that are used a fair number in terms of counts of how many times they're referenced in the function, those variables will be copied into registers and sort of assigned a register throughout the entire scope of the function, which is itself not the most efficient strategy, but it is better than well, just endlessly reloading them and saving them back to the stack, but which is how it is handled for all the other variables. But the goal would be eventually to improve this some, or potentially convince someone to port over a more effective compiler like GCC or Clang or something. But yeah, I don't feel like facing off with that pain right at the moment, and no one really else would really have reason to care, so yeah, probably won't happen for right now. But yeah, I have not yet ported my compiler to my instruction set because, well, it's still way too way too buggy. So chances are it would run out of RAM and crash before it actually got anything compiled. So yeah. But it's, as a thing, has a good solid status of sorta works. And maybe in a few more weekends I might get it a bit more debugged. I actually had the Quake 1 demo working as of last weekend, but I forget, either last weekend or 2 weeks ago. No, I think it might have been 2 weeks ago, but either way, got that working first, but Doom took a little bit longer and a little bit more debugging, so that happened this weekend. And similarly, for getting them to be able to be launched from the shell here and actually utilize test turn, that happened this weekend, and getting the sound module working was also this weekend. And and I think I mentioned getting Doom working. And that happened, well, on Friday, I think. Something or another. As noted, no real significant instruction set changes. A few weeks ago, I did add a sort of clever but nasty hack I had called jumbo instructions, which combine together multiple execute lanes in order to support a single virtual instruction with a larger immediate value. But yeah, so as opposed to spending, like, say 4 clock cycles to load a constant, but potentially executing it in parallel, you can utilize all 3 execute lanes at the same time in order to simultaneously load an entire 64-bit constant. But yeah, so I'll load an entire 64-bit constant in 1 clock cycle. Similarly, using 2 instructions or 64 bits, it's possible to load a 32-bit constant, or also to use 32-bit immediates with some other instructions like compare and add and similar. There were previous 48-bit encodings for that, but for various technical reasons, those ones are currently incompatible with the use of WEX. Or at least, well, they can be used in the same instruction stream, just not at the same time, at least in the current form of the compiler. The Wexifier logic would need a fair bit more work in order to be able to deal with that and not lose its crap, so the technically simpler solution was to add some hacky 64-bit encodings, which conveniently enough aren't actually a separate encoding space from the main 32-bit ops. They're just, some of the 32-bit ops, but with more bits stuck on the immediate via prefix that executes in an adjacent execute lane. So simple hacky solution, not the most code dense solution, but it works. Future of 48-bit instructions is kind of ambiguous, but they might remain around because they do retain usefulness in some cases, namely scalar code. But yeah. As for performance, as noted, this is not exactly the highest performance. As of the last time I ran it, for the Drystone benchmark, it gets around 19,000 dry stones per second, or about around 11 point something or DMIPS, which is kind of in 386 or 486 territory. But yeah. And as can be noted from its Epic, Doom, and Quake performances, and or lack thereof, it is kind of roughly in the performance area of a high-end 386 or a low-end 486. So, yeah. And in other areas, its performances, stats are not particularly good. I think it's, well, a fair bit worse in terms of actual raw memory performance, like actual memory bandwidth and copy speed are kind of pretty sad, even if compared with the original, like 30-pin sims, like 30-pin sim and 72-pin sims would actually probably beat the raw mem copy speeds I'm getting. But in terms of execution instructions like ALU and other stuff, this should actually be a bit faster than a 386 or 486. So it can encode color cell quickly and could potentially do JPEG quickly, but or JPEG encoding or decoding, but in terms of memory intensive tasks like running Doom and running Quake, that's kind of not very good. In terms of Drystone, but Drystone, it's mostly dominated by string compares and integer divide performance, which are both not strong areas of BJX2 either. String compares because, well, that's essentially a variation of a memory operation, like load bytes, compare bytes. Yeah, mostly memory intensive. And integer divide because, well, I don't exactly have an integer divide instruction either. That's just, done in software via a shift, compare, subtract loop. Yeah, not even like semi-optimized by hardware like it was on Super 8. This is basically just straight up loop which shifts values around and subtracts them, or compares and subtracts them. So yeah, it's a bit twiddly. But yeah, I'm probably going to call that all for right this moment. So yeah.